build after the session. Okay, good. Thank you very much for the invitation to have me here to talk a little bit about our experience on developing smart cities in several parts. So basically what we want to talk today is to provide some ideas for discussions about the issues that we have found when trying to implement and develop smart cities in the hard way. Try to do things, see some of the results, the failures, the success, and we try to do join some of these ideas and make an overall proposal, overall framework, how things shall work in order to deploy and to create smart cities. Okay, this paper was written along with Linda. Linda Bauer is here with me, so she's going to present some of the research cases that we did to develop the paper. So we will take some of the initial part, and Linda will conclude thereafter. Okay, so do I use the mouse or? Okay, perfect. So basically, the idea, the agenda for this presentation is here. It's very linear. So an introduction, define a little bit the objectives of smart cities, why ICT projects fails, and this is indeed, when we talk about the smart city, we end up talking about an extension of ICT projects in general sense. So some of the things that apply to ICT projects, we also apply to the development of the smart cities. Then we are talking a little bit more in details about the proposed smart city framework, and this is where I want to have most of your feedbacks. Including the smart cities platform, the IT infrastructure that we need to do that. Let's talk a little bit also about the implementation management, the cases, and how you can evaluate projects, because there is no sense to do something in smart cities without having a way to evaluate the results we get. Talk about some potential business models for deploying smart cities. Talk about the case studies and final conclusions and questions. If you have, I will be glad to hear. So some of the things that are important to talk is that as a general trend, and everybody knows that, is that population is moving from traditional inland areas into cities. So there is a constant migration in the last 50 years that people is moving from farmlands into big cities for many different reasons. So the concentration is increasing. The urbanization is a process that is continuing, and we believe that in a couple of years, more than 50% of world's population will be living in cities. So we need to provide, we need to sustain these people, we need to provide services, give assistance, medical care, security, so all the basic functions that individuals need will need to be provided to a huge population that will be living in cities. So how to do that effectively? So today in the world, there are more than 200 cities with population that are over 1 million people. In my previous slides, many years ago, I was responsible for the education department in the state of São Paulo, Brazil. And my community, the people that I need to serve as a public officer, government officer, was 6 million students, only in one area, one area of the country. So the huge numbers are increasing, and we need to use more smart ways to be able to manage and provide solutions and services. And for sure, so the first idea when we talk about smart cities is that the first thing that comes to mind is that technology is the holy grail to solve every problem related to smart cities. And we will see that normally technology is only one of the important components for smart cities. There are many other things that we need to take into consideration to successfully be able to deploy smart cities. So when we talk about what we want or what we need for smart cities, there is a very interesting or maybe even funny definition. I believe it's from Price Waterhouse. What is a smart city? And they say, well, I don't know what a smart city is, but I will recognize one when I see it. So it is a very soft and inconsistent definition, is open definition for a smart city, but this is a reality because the needs for a smart city A can be completely different from the needs of a smart city B. So, but there are some common ground. So the whole idea about smart cities is to provide better services to citizens. So we need to empower citizens and provide them to ways not to complain. I've heard here that in the morning that you want to have a system to have citizens not to complain. This is part of a smart city. Maybe a simple tool can solve that, If it's intelligent too, then you have an intelligent city or a smart city. You don't need maybe technology to solve that problem. Also, improving the quality of life. So citizens, they want to live a good life. Everybody wants to have a good life. So in big cities, why we have to spend hours and hours commuting in transit, in buses, on subways, and very crowded places, just to go back and forth to work? So improving quality of life is very, very important if you want to have a smart city. Of course, saving money for the government is important, but not only saving money for the government, saving money for the citizen. If you consider that a citizen in a traditional, in a more large city like Mexico City or like Sao Paulo or like Tokyo, may take 2 to 3 hours commuting just to go to work. They're losing a lot of money when they do that. In another article that we wrote a few years ago, we calculate how much is that effective cost of people losing time and converting that loss of time into money. So there is effectively a loss of money when people do not commute fast and properly. Of course, all these things lead to an extreme increase on resource consumption. More energy, more CO2 are being deployed for having these issues. Overall, what we also want in the smart city is that the government have a better performance. They can do more with less, be more effective to do something. And also, another point that is important, also related to some of the projects that I've heard here in the morning, is how do I improve the interaction between citizen and government. So the communication is not just when there is an election, but communication shall be also many times during the years, during the process of the government. So there should be an easy way to consult or to request information feedback about some ideas that the council may have within the city, and not necessarily in a formal way, but maybe a small request, a Facebook page, or something that can provide some feedback information. This is also part of what we call smart city. So the important point is that ICT is probably the best tool we have to do it, because that will enable us to develop the concept of smart city, to implement the smart city in a fast and efficient way. But not necessarily. In some cases, we need to have what is called the smart mayor, not the smart city. That would be an easy way to have a smart city. Okay, and why ICT project fails, and by extension, why smart city project fails. This is an issue that has been studied for many years. Our friends in New York and Albany on the Center for Technology and Government, Teresa Pardo and Anthony Creswell, they have dedicated many years studying and researching these subjects. And this is basically the summary of what they have found out on that. So ICT projects in government fail because governments normally are very stiff on when they manage budgets. So it's very difficult for a government to change, for instance, the allocation of money from one project into the other, or to get additional funding for 1 year into the other. So the ways government manage today their budgets are very rigid. It's difficult to do adaptations and modifications and to adapt to the needs. Another problem that is very common, mainly a little bit more larger cities, maybe not in the city here, there's a small one, but in larger cities, you have the concept of government silos. So you have the Department of Education, you have the Police Department, you have the Health Department, you have maybe the Street and Roads Department. And each one has its own set of problems, and they do not talk or communicate to each other. When that happens, the interest to deploy and develop things, they go in different directions. And in order to be successful in government projects, you need to have a very good coordination. So what normally is missing in government structures is the governance piece, is the coordination part, is the planning part, is the strategy issues that can lead to common goals and common objectives. This is normally a very critical issue that applies either on traditional ICT projects and also applies on smart city projects. Also, the lack of policies that engender investments it's another issue. So normally it's difficult to governments to get money other than increasing taxes. However, there are other creative ways to do that. So there is the concept of public-private partnerships that can be used. Concessions is another way to do that. We are going to analyze later on in the paper this issue. And also, governments are very, very good on what we call the crisis solution. So I can promise that if there is a fire, the fire truck will come very fast to help the fire. However, maybe if you have a pothole in the street, that pothole may be there for a year. Nobody will take care of it because it's not important, it's not visible. So governments tend to work mainly on crisis issues. They respond fast to crisis, but they respond slow to the traditional or stable problems in the city. Okay, so these are some of the points, the main points. It's the paper that Teresa and Anthony provide is very interesting and it goes deeper in each one of these details. So if everybody's interested, there are references to that paper. So what we're starting to understand is that we understand from these issues that there are indeed three important pillars that need to be present in order to us to build a successful smart city project or even an ICT project. So basically, the pillars are you need to have good public policies in place. And we mean public policies, you need to have the laws and regulations and the standards set there. We need to have a good governance model where we can do the planning, the execution, and the control of our projects. And also we need to have resources. And we mean by resources having human resources, people that have been trained and capable. So we need to create a capacity building process to enable us to deploy smart city solutions. We also need to have the financial capability to do that, because without the dollar sign or the euro sign, things do not happen. And we need to have technical capability or technology to do things. Normally what we see when we start talking to most of the governments we talk to about smart cities, the first things they see, okay, what I need to buy to do this piece, what I need to invest in technology to do this. And most of the times the answer is not technology. Most of the times the answer may be on human training, having the right and proper people to solve an issue. Okay? So these are the basic three pillars to provide solutions for or to build the government and to do the smart city framework. So based on that, we need to understand, okay, let's see if we are able to create this pillar. So we will have in place the public policies that we need. We will have a good committee, a steering committee that will help us on the governance part to deploy our smart city. And we somehow can get the funding, train our people, and buy the technology to do the smart city. So what do we do next? Well, if we have those things, we need to have a platform, basic technology platform to do these things. The platform, they have an architecture, they have components, and they have applications that will run on that platform. So what I want to discuss a little bit more in detail is exactly what this platform is. It's a very colorful piece, but it can take here hours to discuss this, so let's focus on whatever is important. So if you look at this framework, you will see on the right-hand side what we call the main city functions. So we try to categorize which are the functions that the city need to perform. And there are a couple of the functions or domains, also called domains, that we need to address. So every city will have issues on transportation. They will have issues with public lighting and energy. They may have issues with providing water to the citizens, how they treat and collect garbage, issues on safety, issues on citizen services, the things that you mentioned. The citizens go to the city hall to receive the services, and many others. It depends. If it's an agricultural city, they may have issues related to crops, as we were discussing, or if it's a fishing village, we can have issues related to the port. So there are specific functions or domains that are related. So we try to separate the different domains, not to mix them, because they may have different solutions for each other. So what will enable these functions to be solved is the presence of the Internet of Things. So having the IoT devices that will be able to measure everything that is happening in each one of these functions in the city and provides to the managed information. We can analyze that information and provide feedback to the area in order how to optimize that specific function. So there are different IoT devices, but we can summarize them on basically you have cameras looking what is happening in the city. We can have sensors in many areas, so we can sensor the rain, we can sensor if a bridge is open or closed, we can sensor if a tunnel has light or does not have light. We can sensor if there is people waiting on the traffic light to cross. So we can sensor many parameters in the city, and we'll collect all that information to feed our systems and analyze that information and provide feedback to the city and better operate that city. So another important issue is that we also the process of a smart city is not only one way. So I've seen some papers that only understand the smart city as collecting information, but the smart city also needs to provide information back to the different elements that are present in the city. For instance, the city of Miami, everybody probably have seen these pictures. They have those bridges that open and close, hundreds of bridges across the city. Normally, you have one operator that is there 24/7 operating that city. Why? We really don't need that. With the proper number of sensors and actuators, we can make this process automatic and sometimes more efficient and sometimes more safe, because sensors can measure many things, not only the boat that is coming, but can sensor is there people on the bridge, is there people trying to jump in the bridge, are cars waiting, so you can optimize and maximize using the proper algorithms to do that. Okay, well, when we talk then about the second layer, we have now the third layer on the middle of the slide, is Wi-Fi communication infrastructure. Indeed, this is basically an internet, probably an internet communication, doesn't need to be internet, but could be. It's the way we can get all these devices, all these IoT sensors devices, connecting to our central information system using remote connection technology. These technologies can be Wi-Fi, could be Wi-Fi Max, could be GPRS, cellular mobile, could be mesh networks like Sigfox. So any communication infrastructure can be used to connect your IoT device into your main infrastructure. For sure, you cannot do that only for a single solution. You need to have hubs with different areas in the city that will take care of that. But that hubs will then accumulate the information, will summarize the information, and will send this information back to the different databases that we have for smart cities. And here it's important to understand that we may have multiple databases available for smart cities. So these databases, they are composed from legacy systems. So the traditional systems that are already in place, they will be also part of the overall smart city solutions. So things that we used to do in the past, like tax collection, permits, records, cemetery control, everything is part of the smart city process. The data is there, we just need to analyze it. So the other bigger group of information that is available for a smart city is the big data information. The big data information is the data that is collected from these hundreds of sensors that are present in the city. However, the big difference with big data is that the number of data points in a big data element is huge. Each one of these sensors that you see here are collecting hundreds of data points, of thousands of data points per second. And all that information is going to be stored on the big data databases. There are huge elements of data, huge clusters of data. And the problem is that today we have technology. It's not a problem, this is a solution. In the past, we didn't have the technology to handle this massive amount of data, either to collect, store, and process. Today, with cloud computing, we do have that technology that can use things like Hadoop or multi-table processing to do this analysis and evaluate the amounts of data. Another important thing that we need to understand in the smart city is that the city will become as smart as we are able to create business rules. So normally what we do today is when we have information, we have somebody that can take that information and make a decision. As we start to understand the behavior of the city, we can start to automate the, the solution or the answer to the problems through what we call the business process rules. So the BPMs, areas that you see in some information systems, they will also be uh, brought into the smart city overall framework solution. Good. So far, so good. Any questions? No? Great. So now, related to the process side, when you have all this huge amount of data, these massive collections of clusters of data, then you can really start to analyze those things and provide the information that you need. And basically, we try to categorize the solutions for smart cities in three big areas that you see on the bottom in green. So you have the area what we call business intelligence, analytics, indicators. So this is the part that we will use to provide decision makers with the information they need to make decisions. So normally when we talk to smart city projects, when we talk about the BI analytics indicators, these are the numbers that we are going to provide to the mayor, the numbers we are going to provide to the city council, so they can understand what is happening in the city in real time and take the decision, whatever it is. Okay. On the second group of applications is what we call the city operations, or more traditionally the management information systems. These are the systems that are used on the daily operation of the system. For instance, somebody is paying his taxes in the city, somebody needs a record for a property, somebody needs to have a license to put an advertising on his billboard, or whatever is the problem the city needs to manage on the daily basis, a transactional fact. This is done on the city operations management information system. Of course, we need a group for IT management itself, so the whole IT department needs to manage itself, so this is also a very important group of the process. And the third and most important one is on the app, for you on the upper right corner, the end user application set. So end users also will benefit to having applications in his mobile phones or his notebooks or PCs or even on smart watches to provide information about the city. So how do I reach point A to point B, or when is the next bus coming, or what is the process to pay a taxes? So I can ask my phone how to do that, or which is the best restaurant in town. So all those informations can be provided by end user applications. Then I mentioned briefly which is the best restaurant in town. This is a smart city application, but is this a responsibility or is a government responsibility to develop that application? Probably not. Okay. So here you start understanding that for many solutions for a smart city, it's not the government who's going to provide, but the government can provide the basic infrastructure. So third parties can start developing applications to the end users to make the city more smart or a smarter city. Okay. This is basically the components defined, so you have it at the presentation. I went to each one of them. In here, I would like to bring Linda to talk a little bit about that area. It's mine or yours? Next one, okay, good. So let me just summarize what we saw here. This is basically the different domains and examples. So you've seen this table. You have on the vertical the different domains that can be used for each one of the cities. So you have domains like traffic and transportation, energy and environment, safety and security. And so we can define multiple related domains that can be managed by one. And then you have the different audience that will benefit for smart city solutions. So we classify them basically in three different groups. Solutions for decision makers, high-level solutions, high-level information, normally based on dashboards. Then you have the audience of city managers and operators. This is the traditional management information systems, or what we used to call before the e-government solutions. And then finally, solutions for end users or citizens. Okay, good. This is an open table. Everybody can play with this table, including all solutions and non-domains and non-verticals. But this is a way that help us to understand how to classify things and how we can work. Of course, when you're going to deploy a smart city project, it will be impossible to deploy that at once. It's very, very difficult to do that. And then it's difficult to do each one of these small rectangles here. So normally what we do when we go to look at the smart city, we try to identify together with the population and the government of the city, which are the domains that are more interesting to work, the one that affects more the life of the city. And then we start working on that priority. Okay. Okay, so how much time do we have here? No, I know, but how much time we have on the session? Yeah. Okay, so we have 2 more sessions to go. Okay. Okay, no, we are good. Okay. Okay. Yes. Yes.
Do you really see? I mean, I believe in standards. I'm following this ISO standard, the latest ISO standard of sustainable city development. Some work done with the British Information Bureau. Do you think they are important? They can really play a role.
Yes, they are important, but they're not absolutely necessary. As long as you have the means to convert standards from A to B, that's something that can be addressed. But we need to have at least a basic set of standards. For instance, if you're going to do communication in a city, it does make sense to set a basic communication standard for the whole city instead of having multiple standards having to support multiple communication standards. So there are some basic standards that are really important to be there present. But there are standards that fluctuate, that standards that goes into place, and then after a few years you have to drop that standard and replace it with something else.
I was talking more not on the technology standard, of course. If we take Wi-Fi or if we do mobile, we have some standards there. There are some standards that try to regulate in a way or propose some directions smart cities themselves. So there is a standard on an ISO standard on sustainable development, city development, that tries to say how a smart city should look like as a standard and how to measure it.
That's I do not agree so much. But Linda is going to talk a little bit about standards for evaluation. We need to adopt, yeah. So that's a different conversation. Well, there is the city protocol that's trying to do this, but I think it will be very, very difficult because the needs of the domains change a lot. So it will be very difficult to do those things. Okay, I think I'll pass now to Linda, so she will talk about the cases that we analyzed and the process.
The implementation process is very important in itself to the success of a project. This is the depiction of the U.S. government, the federal government's process for IT investment. The main components are select, control, and evaluate. And they all feed into each other. They're not separate steps. Use it. Oh, It's an iterative process. You have to have a standardized approach with systematic process. As any project, smart cities projects need to be evaluated. Was it worthwhile? Evaluation offers lessons that can be learned and applied to the next project. Was it successful? If so, what are the elements that contributed to the success, and can that be applied to the next project? Some projects can yield value of different forms: economic, financial, social, institutional. Some outcomes are very straightforward and can be measured quantitatively, such as the money that an agency saves when it implements a project, or an increment in the gross domestic product when a project impacts the economy as a whole. Other non-economic outcomes need to be measured in other ways, and there are methods to do that. Mentioned those developed by the International Standards Organization and the Social Progress Index. The ISO has developed a couple of standards, one with a model for designing and developing a quality management system, and another one to measure, monitor, and track the performance of city services. It has with a uniform approach for what is to be measured and how measurements to be taken, but it doesn't make any value judgment of any particular index element. The Social Progress Index offers a framework to measure social progress in several dimensions: basic human needs, well-being, and opportunity. For example, it has indicators on access to health care, water and sanitation, access to information and communications. The developers of this index hope that it will become as important as the GDP in measuring a country's success and progress. And in fact, it is beginning to be used alongside the GDP. For example, Paraguay now sets targets in social progress index parameters, as well as setting targets for the GDP. There are traditional city functions can be owned and operated under different business models, and so can smart city projects. There's the traditional government ownership and operation, public-private partnership. That can be the case, for example, where a project requires a significant investment and has a long-term goal, where a private company would not be willing to make such a big investment over such a long horizon. So the city may finance it and then turn over some or all of the operation, ownership and operation, to a private enterprise. Then private ownership and operation under different forms, under a concession, where one company gets exclusive operation in a certain territory, under a license where multiple licensees can compete, and even free market enterprise competition can help cities be smarter when they offer functions and services that help make living in the city easier. We looked at some case studies: Boston, Trans-Santiago, the transit system in Santiago, Chile, ride sharing and bike sharing. Boston, its digital strategy, it's so committed to its Smart Cities program that it rebranded its management information System Department to the Department of Innovation and Technology. Do it. They have followed all the precepts that Lorenzo gave in the framework. They have the commitment, they have a vision, they have the overall planning, a strategic plan, the adequate resources have been allocated, and they have been so successful that the American Council for an Energy Efficient Economy named Boston the most efficient large city in the United States in 2013. Since we're pushing on time, let me let me let me skip to the last one, the bike sharing, because we're pushing on the question and answer period. The bike sharing. Bike sharing is very interesting. It offers a new component in urban transportation. In cities where it operates, a network of bikes is available at various docking stations around the city, or even in the metropolitan area in some cases. People join online and they get an electronic card or a digital code. They can go to any bike station, unlock the bike, and ride to their meeting or wherever, and dock the bike at another station. They can even, in many cases, check the availability of a bike at a certain station on their smartphone. They're in operation in about 200 cities now in varying degrees of success. In Washington, D.C., it's very successful, popular, and growing rapidly. It has grown beyond D.C. to other areas in the metropolitan area. Another one in Seattle, however, has not been so successful. There were some problems with overestimation of demand in the forecast, and not enough resources, not enough coverage of bicycles, so that it wasn't very useful. Last year, they were found to be insolvent. The city took it over and is injecting money to help try and turn it around and make it successful. The interesting thing is both of those systems are operated by the same company. Motivate International is one of the major bike sharing companies, and they have operations besides Washington and Seattle, Boston and Chicago, and New York. The one in New York is very successful. It's City Bike. They have sponsorship from Citibank, and it's very popular and successful. So the summary, the next one. The next one is just the summary of all the case studies we looked at. It'll be online. Lorenzo will come back with the conclusion.
That slide presents the different cases that we study, most of them related to transportation, because transportation is the most critical issue for most of the cities. So you see that basically none of the issues were technology for implementing a successful project. The issues were related to policy and governance and resources. So that leads to the overall reason of having this framework where we support the three necessary pillars: the governance part, the policy part, technology and resource part, and the commitment part. Okay, so the conclusion is that we really need to pay attention to other things not related to technology in cities. We need to have a platform to provide a good management capability to implement the different applications based on a common ground. Um, need to analyze different business models, not only having government provide the solutions, but having models that incorporate public-private partnership and fully private operations of things, and have the metrics to evaluate the cases. Okay, so this is the main message. Is a proposal. We need to develop the project. Sometimes have to redo it, like the case of Seattle, in order to ensure that we're be able to have successful in the future. Okay, so we'll finish here. If there are questions, I'll take the questions later on. Thank you very much for your time, and hope to be back next year. Okay, so if you have questions, I'll take the questions later. So let the purpose of time, let's call the next presentation. Cristina, come here.
The title of my presentation is Designing Smart City Interventions for Islands. Okay. The aim of this presentation is to investigate in which sectors we could take actions, promote projects, and develop digital applications in order for islands to join smart cities. The contribution will be the documentation data and the analysis of the demands of the needs of an island. We will attempt to include citizens' opinion, the organizational, technological, and economic status of an island, and the experience of qualified personnel from other smart cities in Greece. We use the multi-criteria decision analysis in order to develop and select the best application scenario for an island, and through which specific digital priority applications will be proposed for the island. The contents of this presentation are as follows. We will attempt to give the definition of a smart city, and we will try to identify why islands have unique characteristics which bring specific difficulties in smart policies. Then we will present our methodology and how the multi-criteria decision-making analysis helps our work. We will also present you a case study about requirements analysis and suggested specifications of smart Samos applications, which was the title of my master thesis. And the presentation will end with the conclusions. Now, what is a smart city? It's a city that uses digital technologies in order to improve the quality of life, reduce costs. Why a smart city is useful? Because the life will become easier, the city will have competitiveness and prosperity. How we can make a city smart or smarter? We need a strategic plan, social participation, and we need to formulate a vision. We see 10 key areas of digital interventions in which a city can develop smart actions or applications. These are energy, transportation, information and communication infrastructure, healthcare, water and waste management, e-government, citizen safety, local development, culture and tourism, and environment. Now about smart islands. An island is an isolated, self-contained territory. An island has specific characteristics that are key factors, especially in the Mediterranean. These are the poor availability of data infrastructure, the lack of available services, and the special social economic conditions. Now, designing smart city interventions for islands. We first must structure the problem. We believe that we select a list of smart applications as a result of the literature review, citizens' voice, and the opinion and experience of municipalities officials. And we select a list of criteria, and we select the weights of these criteria. And then we rate the application in order to have the best solution for an island. We use multi-criteria decision analysis as a tool for our work. This multi-criteria decision analysis is a valuable tool that we can apply to many complex decisions. It is most applicable to solving problems that are characterized as a choice among alternatives and helps to select the best one when the decision maker has multiple objectives and criteria. The criteria weights are a result of our preferences for the criteria. For example, which one is most important. We must first identify the criteria, rate the criteria, and then the multi-criteria decision matrix is a matrix, as the picture shows, where each rows are the preferable applications we have selected, and each columns are the criteria or sub-criteria. We apply a mathematical type in order to combine the score of each application as this table shows. The time plan, this picture shows the time plan of the Smart City initiative. The initiative consists of 3 phases. The analysis phase, the piloting phase, and the development and maintenance phase. In the first phase, the analysis phase, the first phase includes the presentation of the citizens' voice by analyzing the data that comes from relevant questionnaire. It also includes the literature review and the Greek and international best practices. The first phase ends with analyzing the current status of the island municipality. The second phase, the piloting phase, the piloting activities will concern the 10 key smart areas we described before, and the piloting phase will end up with evaluation and replanning. The development and maintenance phase concerns concrete project implementation and replanning.
Now, this is our framework. And you see, what we do is we have these 3 questionnaires. So it's the citizen's voice here, and it's the employee's voice. You call it managers, something like that. And then we also took an interview from the mayor. tell him, what is your idea? What is your goal? Kind of the policy maker. In a municipality, especially in Samos, which is not a very big one, the policy maker is the mayor. He sets the priorities. And so we share the same view. Citizens, employees, and mayor. And basically, these were the three questionnaires we had. And then we analyze the results. Anyway, the questionnaires are structured in a way that you have to say, yes, I like this, or no, I don't like that, based on the 10 areas. And the proposed solution. The difficulty is that we needed to spend a lot of time to develop a set of 100 possible interventions. This is something we should standardize sooner or later. Say, the possible interventions, all the map. Yeah. I mean, this would be nice to have, it can be 200, I don't know, it can be 300 even. All the possible interventions. This is something every municipality will have to see. And then, with this criteria model, which is a way to factor issue, we try to propose at the end the final intervention. Now, we are somewhere here now. We are somewhere in this piloting phase, meaning some of them have been prescribed, some of them are starting, some of them we're looking for the financing with the municipality to start in the next months. Yeah. 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 And this is what I said before. The more we have these 100 interventions issued, map, the better. Because, yeah, you say, we ask the citizens, what do you want in your smart city? If they don't know, they will never know. That's why we provided them, we try to provide them with 100 interventions at the level. We were at the level of 100, maybe a little bit less. Yes. So we showed them the menu. Some of them don't even know, maybe didn't even know what that thing was. Some others knew, some others said, yes, this would be nice. I never thought about it. So we try to do the rating based on the menu. Because if there is no menu, so we need to develop a community, needs to develop a menu. The practitioners, we need to, the researchers, we need to do something to develop a menu. This is my next semester thesis. It's under implementation now.
Our case study in Samos Island. A few words about Samos. Samos is an island. An island lies in the heart of northwestern Aegean Sea. It has almost 33,000 inhabitants. It's a small geographical area with serious problems, such as continuous decrease of population, deficiencies in infrastructure, minimum degree of exploitation of resources, and development problems. On the other hand, it's an island with tourism growth and significant activity in the community, regional and national level. It is famous, its production in wine, olive oil, honey, and other traditional products. The aim of our methodology, this work aims at developing a methodological approach of project smart actions, which will give the necessary guidance for the integration of Samos municipality in the field of smart cities. For this purpose, we performed an analysis of the requirements and needs of the island. The aim of this work is the construction of specification of the actions that will prepare Samos for the development of a smart city. In particular, we drafted alternative scenarios proposals will be the basic concept for the implementation of applications which will be tailored to Samos needs, so in the future to form a key strategy document for Samos as a smart city. The stages of our work was 3. In the first stage, we had 3 steps. In the first step is the citizen's voice. A questionnaire was given to citizens in order to investigate the factors that shape the citizens' attitudes towards the online services offered by a smart city and their intention to adopt them. In the second step, a questionnaire was given to the municipality of Samos officials and employees in order to map the current situation of the municipality. In the third step, a questionnaire was given to other smart cities in Greece in order to share their experience. The second stage was the data collection, data analysis, and in the third and final stage, we used multi-criteria analysis in order to choose the best solution for Samos. The tools we used was Google Forms for the questionnaires and Excel. Now, 449 Greeks participated to our research, and almost 33% of them lived in Samos. Among the 10 key sectors we discussed before, citizens of Samos highlight the e-government sector as a need for Samos Island. Areas that citizens believe that it must be developed smart Samos applications. In this diagram, we see that citizens of Samos want a tourist guide first and e-services from the municipality. The key actions of Samos municipality according to its operational program is e-services, firefighting, and this diagram shows the answers of the municipality employees about smart applications in Samos. So, as a result of this first stage, citizens of Samos show great interest in developing smart city applications. The municipality has the operational objectives and priorities of smart application development in Samos, and the municipality officials will help to make a project vision of the new digital era in Samos. Now, the multi-criteria decision making. In order to make a decision about best smart solution for Samos, we must first identify the criteria. The next step is to identify the weighting of each criteria. So, according to what it really matters, are the criteria and their weights are as follows. We used 3 criteria. The first one is the municipality's degree of reliability. Here you can see the sub-criteria with 45% as the weight. The second criterion is citizens' opinion, and the third criterion is the application mature grade. A proposed list of 37 digital applications and intelligent actions for Samos, categorized in 10 key smart sectors, was drafted and selected after a literature review, analyzing the results of citizens' voice and analyzing the results of the opinion and experience of municipalities' officials. Obviously, this list may grow and added with new digital applications suitable for smart cities. We rate our options against the criteria and then multiply by the weightings. According to the decision maker's preferables, we may change the weights of the criteria. According to the score of our list of applications, we classify them in three categories. Those who have low priority, those who have medium priority, and those who have high priority. So here you can see our multi-criteria decision matrix. In the first column is the sector, and in the second column is the specific applications we have selected. And after applying the mathematical type, we had a value, a score for each application. It's a big matrix. The result is that what is the result of this matrix? The development of an information tourist guidebook with real-time information to the visitor, and the coverage of Samos with free Wi-Fi spots, hardware infrastructure, and back-office applications are the main applications that we must. Is the result of this work. Next steps in this work is, of course, the implementation, the evaluation, and the planning of the project. Thank you very much.
I have a question, and then another one. Okay, could you go back to the model, how you weight things? No, next one. Okay, how do you decide on the weights?
Yes.
Which matter more, or
it was what we believe that it was good to wait, but according to the decision maker, someone can change this weight. We believe that in order to have smart applications in the municipality, in Samos, we believe that the municipality's degree of reliability and how ready is the municipality is it matters the most. That's why we weight this first criterion with 45%. But it was our choice. Someone can play with these weights in order to have different results.
So how did you determine the application maturity rate? So you had three rates, and the third one was application maturity.
There are sub-criteria. For each one of these three criteria, we had sub-criteria. As far as the third criterion is concerned, we had 5 sub-criteria: experience from other smart cities, the application, how can develop the application, the costs, the maintenance and support costs, and the company's credibility. Yes, if we can use a company that already has this application.
So each criteria, are they from your own interpretation, or did you discuss it with policymakers, for instance, or where do these 5 come from?
No, this is our what we think that we must count on a decision. All these sub-criteria we think we must take in our minds for a decision.
Tricky point, this one, but there's no correct solution. You see, you study a little bit on literature, what happens? For Samos, it's important. We rated 45% the reliability and the readiness of the municipality, because otherwise nothing goes on. In my opinion, it could be even higher, like 50%. You don't make it there, you don't make it anywhere. So if the system is not ready to support the solution, forget it. And this is critical for somewhere like Samos, that you cannot expect infrastructures to be top-notch. For example, in New York, even if they don't have it, they will find it and fix the infrastructure within weeks if they want. In Samos, if you don't have a Wi-Fi infrastructure, for example, somewhere, it's not so easy to say, yeah, I will do it next day. And the third one is about, maturity, because you see, in Greece, we suffer a lot from companies disappearing. You see, there's a company coming, say, I have this very nice solution. And then you say, give it to me. He starts, he deploys, and then disappears, closes down, shuts down, cannot support. You see, support is important also, and the cost for that. So it's a kind of, you will never be correct, I think, 100%. You just need to put some factors, do something, and then reevaluate. As we say, there is at least one rating scenario that will make your solution better than mine. But then there's another ranking scenario that will make mine a little bit more important.
The other question is, have you proposed some of these applications which are specially connected to the island character of Samos, or most of them would be equally important for a city on the mainland?
No, it's particularly for Samos. This matrix shows the values, the results are particular for Samos, which are the best solutions for Samos, the best smart applications, only for Samos. Yes, as we see here, we have the three criteria, and the values in this criteria was a result from citizens' opinion, Samos citizens' opinion, Samos municipality employees and officials. So this matrix concerns only Samos, and the results shows that the need, the priority need for Samos was a tourist guidebook and e-services for citizens. But someone can use this model, probably maybe with different weights in the criteria, for other cities or other islands. Thank you.
Now, as Harris is going to plug in our Skype participant, Irini Matzakou. Irini was sitting where Angeliki is sitting now and controlling the presentations in the first Samos Summit. He used to work for the National Technical University in Athens. Irini is following her PhD there. Now works with Intrasoft International. Intrasoft is one of these very big companies in ICT in Europe. Is, as we say, originated in Greece, but now they have offices all around the world, and especially Brussels. And
Hello.
Irene is going to talk about the Optimum project. Irene, I just finished your introduction. Can you hear me? We are being transcribed to Harris. Harris is talking to the inside. Okay, but we can hear you very well. So, Harry, you run the show.
Okay, thank you. Thanks for an introduction that you have made for me. Thank you for giving me the opportunity to speak today and participate, even remotely. I wish you good luck to the summit and to all your activities. Let me introduce also myself. My name is Irene Madzakou. I am a Research and Innovation Manager at Intrasoft International. And today I'm going to talk to you about the Optimum project and our activities and what the results we're expecting and how we are contributing to the smart cities and smart mobility concept. So I assume that you see my first slide for the time being. Okay, so let's go to the overview, please. So this is the structure of my presentation today. A few things in the beginning about the Optimum project, the general context and the domain that it is related to, our objectives, our work structure and our pilot cases, which will be the proof, let's say, of concept and of what we are doing. And then the results and the impact that we are foreseeing to make. So let's go to the next slide, to the Optimum in a nutshell, let's say. So in this project, our aim is to develop IT solutions, and when I say IT solutions, I mean web and mobile applications, whose essence is going to be to promote and to improve transportation and transit and freight and traffic connectivity all around Europe. And the core of those web and mobile applications is going to be how we're going to be more proactive to understand better the traffic situation and the traffic data that we're having on our hands, and how we're going to use them so as to have as much as possible, let's say, problem-free mobility. And the basis that we are going to use for implementing this is the interoperability, adaptation, and dynamicity of the systems that we are going to integrate in our work. So let's go to the next slide to see in more detail the project placement. So if you see also the title of the project is a big data project in principle. We are basing our work both on historical but mainly on real-time data, their process, their management and analysis, so as to get some added value knowledge out of those. So based on this data, further scientific and technological context of our work, of our project, is the transport and traffic modeling, forecasting, analysis of travelers' behaviors, travel planning for multimodal mobility around the cities, and also predictive analysis, incentive schemes, and persuasive technologies and techniques, so as to fuse all this knowledge and all this analysis out of those data into the everyday end users. And the general, let's say, placement of this project, if you click on my slide, is the Intelligent Transportation Systems, the ITS domain. So let's go to the next slide, the Optimum objectives. Via our work, we are main aim to focus on three pillars to serve, let's say, three different cases: dynamic toll charging, multimodal routing, and smart motorhome mobility. And of course, since we are a research and innovation project, our objectives are not only focusing on those three research pillars, but also on the innovation part, in order to create applications that are sustainable and can be commercialized and further targeted to the users and to further adaptation from users and from the general domain, so as to achieve a long-term impact out of this project. So let's go to the next slide and to see those objectives, starting seeing them in more detail. So the general approach that we are following in Optimum project has 4 layers, 4 steps: the observe, the orient, the decide, and the proact. As you may see from my slide, the observe refers to the monitoring of the data that coming out of transportation systems and mechanisms. And then to the orient, which means that we analyze and process those data and we can create some services out of those. The decide layer, which help us to create recommendations and some models out of those data, and then the proact layer, which, sorry, interruption, okay, which gives to the users the incentives and the persuasive, let's say, techniques so as to follow certain behaviors in their everyday life. Let's go into the next slide to see this in more detail and in a more comprehensive, let's say, way. So the first layer, the observe layer, it includes all the big data coming into the platform out of smart sensing systems and out also of social media and other user-generated data. All these data in the second layer, in the orient layer, are being analyzed and processed so as to understand what information they have, and so as to create predictions and forecasts out of them, some added value information, let's say. Then we go to the decide layer, where all those analyzed and understood data are being modeled, and patterns are being created out of them so as to understand and to develop sustainable transportation behaviors. And then all those models and all those patterns are being fed via the applications to the final users, via recommendations, via proactive decisions, via persuasive actions that tell to the user what to do and what behavior they should change, for example, in their everyday life and use of transportation data. This is going to be more tangible in the use cases, so I will explain it in more detail later. In the next slide, you see the conceptual architecture. I'm not sure if you can, if the analysis is good, if you can see it in a good scale, let's say. In any case, on the bottom part of the slide, you see the data sources that are being fed into the platform. This is the observe layer, as we said. In the orient layer, these data are being harmonized, they are being cleaned, and we make all the analysis and process so as to create the predictions that we said about traffic and about events that might happen, as well as various forecasts. And then all those results are being fed to the decide layer, where after we have got some idea from those data, the patterns and models, as I said, are being created and then fed to the last layer of the architecture. This I'm going to also explain, as I said, also in the pilot cases. In any case, all those recommendations to the users are being fed then to the applications, web and mobile ones, and applied to the pilot cases. Let's move first to the next slide to say a bit about the project logistics and time plan. It is, as I said, the research and innovation action in the Horizon 2020 framework. It's going to last for 36 months. Coordinator is Intrasoft International. We have 19 partners from 9 different countries and the budget around 6 million. We're now at the 14th, 15th month of project execution, and we are finalizing the technical architecture before we kickstart with further development and pilots. In the next slide, you may see a snapshot of one of our plenary meetings with our consortium, some of our consortium members. They are in front of an Adria smart motorhome, which is explicitly devoted to the purposes of Optimum project. In the next slide, you may also see the map of the project and of our consortium. As you may see, there are a lot of partners all around Europe. The pilot ones, Birmingham, city of Ljubljana, Austria, Vienna, technical partners from Portugal, Uninova, for example, the University of the Aegean as well. In general, there is a good blend of partners, both from technical, scientific, and commercial domains. So let's go now to the next slide, to pilot one, to explain the real case, let's say. Okay, I have only 5 minutes. Good. So the real thing is, in dynamic toll charging, what we are doing, 10 minutes. Okay, good, thanks. So, dynamic toll charging, what we are doing here, first of all, the country of implementation is Portugal. Our end users are freight operators and logistic companies. For example, Samos is one company from Portugal. They have devoted 10 of their freight trucks for us. The essence here is to get both historical and real-time data and understand around the various periods, both of the week and of the year, what is the traffic situation, if there are high CO2 emissions, if there are other events that might take place. And this helps traffic networks to prepare and calculate new toll prices for those freight operators, so as to give them incentives to move from the urban locations to the highways, so as to facilitate both their routes and their operations, but both to facilitate the situation in the urban areas. And based on those tolls and lower prices, of course, in cases, so as to give them incentive to change their routes, they plan their routes, and the result out of all this process is smarter logistics, reduced fuel consumption and congestions, and better use of their costs for the logistic operators. And this case, of course, can be adapted to further scenarios and other end users apart from logistic operators. But this is our case here. So next slide, we go to the pilot 2, multimodal routing. Here, our countries of implementation are Vienna, West Midlands in Birmingham, and Ljubljana. The end user here is the everyday traveler, and the essence of this application is to get both, again, historical and social media and real-time data out of large sensor networks. And here the Optimum mobile applications are going to help users to plan their trips in advance. If they want to use different means of transportation, to prepare a plan in advance based on the best blend of means of transportation. For example, if you start with your car and if you see traffic in the road, then you get an incentive from the Optimum application that says, okay, leave your car in a park lot, and we offer you a ticket for free to get the metro or the subway, for example. Or if you try another one route, then if they sense that an accident has happened or there is something other going on, then again they proactively give you some recommendations, and they tell to you, okay, you can reroute or you can select another means of transportation. So the impact of this approach is to balance the traffic flow volumes and to create a sustainable, let's say, transportation mix into the city, so as to improve people's experience and transportation in general. For example, if you go to the next slide, you will see those people here. They use the Optimum user and the mobile application of Optimum. It's an example of incentives, behavioral persuasive technologies, where you can use the application and see what are your CO2 emissions, and then you see also your friend's CO2 emissions, for example, within a week, and you see that the other user has done better than you. So next week you decide to also use better and more sustainable ways of transportation, so as to again be better and to compete with him and to reach another level. It's like a gamification concept, and research shows that this works on people so as to change their behavior towards better and sustainable technologies. And the third pilot case is applied in Slovenia and the Adria smart motorhomes. Here there is no that much uh, participation, let's say, and interaction of the driver, of the car driver with the application. It's more of a helpful application that focuses on cross-border trips, on organized trips of many motorhomes traveling together. They again plan their trips, advise them during the way of concessions or of for example, accidents, or if they have to refuel their cars, where they go, or other leisure suggestions, so as to make the whole experience more pleasant for the travelers. Again, this has an impact in their behavior and in the general context, let's say. That can be also applied to other vehicles in the public transport, apart from our case of the smart motorhome. So let's go to the next slide, the expected results and the impact. Okay, starting from those applications, so we understand better what's happening around the transportation networks, what information we have, how we can change our behavior and our daily routines, and of course have a more wide, let's say, impact to the whole intelligent transportation systems domain. If we go into the next slide, we will see some more details about this impact that we also aim to measure via various KPIs within the project. For example, the improvement of the travel efficiency, reduction of waiting times, avoidance of congested areas, improvement in the efficiency of general operations, travel times, delays, other disruptions, shifts from urban and national roads to highways. And if we also in the increase in effectiveness and safety of tourists that might use our applications, so as to offer them more pleasant and safe and secure traveling. Apart from that, in the long run, we aim to promote into the market new strategies and that will result from our activities and models and algorithms and general lessons learned, let's say, for better utilization of the public transport services. And in sustainability means, as I have already mentioned, out of behavioral techniques, users can be engaged and to use more sustainable modes of transport, to improve their well-being, to have more sustainable in general travel and transportation network. And also out of our activities as Intrasoft mainly, but in general, we aim to follow the Civitas initiative development so as to help cities achieve again sustainable, clean and energy efficient urban transportation techniques and systems. Again, I'm not going to repeat those impacts. I just like to mention that we specifically address explicit political requests, let's say, that are currently requested by the general environment and DC as well, so as to reply and be compliant to them. And regarding standards, in the next slide, Optimum is observing at all times all the developments of the CN group. We see collaboration with its working groups via our pilots, in order to ensure that all services that we develop are compliant with the relevant standardization efforts, and if we can, of course, during the course of the project, to contribute to new efforts when required. And in technical, of course, means again we're trying to be compliant to data models, to other frameworks that are currently in place. So if you need to learn more about us, in the next slide, you can visit our website, or you can follow us on Facebook, LinkedIn, or Twitter. And that's all for me. I hope I'm in the time frame that you have given to me, and thanks a lot for your attention. I hope that you have enjoyed it. That's all for me.
Questions? Yes, Jan.
If you say something, I cannot listen to you very clearly.
Okay. How close do I have to go to? Can you hear me now?
Okay, you said the question, it was repeated.
Okay. I just wanted to ask on the practical note. The two other projects to me seem like quite direct competition to, let's say, Google Maps, Base, and applications like that. How do you practically want to get users to use them when they already have these quite convenient tools? Because you need the mass of the users to use the applications, right?
No. Okay, to be honest, we're having behind of our applications a large scientific, strong scientific, let's say, background, and also we are aiming to go beyond this let's say competition with new features and integrated. We are currently having this first market analysis, not market analysis exactly, environment analysis of what is out there, and our aim is to find services and ways just to be different and to offer more added values and more smart, let's say, ways to offer those services to the users. So that's the first and initial approach that we're having to make this to outstand, let's say, out of this competition.
Okay. Seems to me they don't have a clue how to do that. But okay, yeah, it's gonna be tough, Irini, to outperform Google. Now I have another question. I'm transferring a question from municipality of Samos here. And the question is, how can a municipality like Samos take part in your project, or maybe use the benefits of your project, or maybe become a pilot in your project? I saw you have Mytilene, yeah?
We have HIOS, not Mytilene. It's HIOS, yes, it's Amalia Pavlidoropoulou from the Department of Shipping and Transport, who is leading from the Samos. Yes, one pilot case from Samos would be very interesting. I don't know, I'm not sure if you have any open data available on your site, any data portal, I don't know. But in any case, yes, you could be a nice use case. For example, I don't know if you could be a multimodal, or I don't know what transportation networks are over there.
Okay, as you speak, we are gesturing here with the people. So I have Yannis, one of my students working with the municipality, Yannis Konstantinidis.
Yeah.
Okay, we'll send you an email to give us some details. What would you like from us so that Samos, which is collaborating with Yanis, then Samos municipality becomes a pilot so that we use some of your technologies and then you also get another pilot user from the Aegean. How does that sound?
Okay.
Okay.
I'm happy to help and to see it in more detail.
Yeah, yeah. And maybe we can even persuade another island. Amalia, you know, is our vice rector in the university.
I know, yes.
We want to promote more islands. Okay. I'm happy.
Good.
Mr. Chairman, back to you. You chair the session, you say if you're happy. Okay.
Okay, thank you very much.
Okay.
Bye.
When